This is Algebra 2, Lesson 1-5, Part B. So we moved on to compounding inequalities. We can join two inequalities with the words or the word and to form what we call a compound inequality. To solve a compound inequality containing and, we must find all of the values of the variable that make both inequalities true. So solving an and inequality, we have these two inequalities. 7 is less than 2x plus 1, and 3x is less than or equal to 18. As we want to solve each one of these on their own and then compare what we get for our answers to find all of the solutions. So we're going to start, subtract 1. Remember, you solve an inequality just like you would an equation, except the only difference is when you multiply or divide by a negative number. We end up with 3 is less than x, which I like to rewrite as x is greater than 3. Solve the other one, 3x is less than or equal to 18. We're dividing by a positive, so we don't have to worry about flipping the sign. So we're left with x is greater than 3 and x is less than 6. So we want to go now and graph that on our number line. We'll start with maybe graphing x is less than 3. We need to have 3 on our number line. We have 3 and 6 as those points, so we need to be able to have both 3 and 6 on our number line. You can put the numbers in between those if you want. Just put a few of them on there maybe. There we go. So we're going to graph x is greater than 3. X is greater than 3 is an open circle at 3 and it points to the right. Now, careful because you don't want to extend the arrow all the way because you still have to also say x is less than or equal to 6. So we're going to go with 6. We're going to put a closed circle and we're going to go to the left. So we're going to connect that with that x is greater than 3. So that space in between that I shaded in blue and the closed circle at 6, those are all your possible solutions for this one. If the variable part of an and compound inequality matches, what you can do is you can collapse it. So for example, on this one, if we solve this one, we can subtract 1. We get 4 is less than x, which is x is greater than 4. Solve our other one, subtract 1, x is less than 12. What we can do is, since these both have that same variable x, we can combine these into one inequality. The way we write that is we put x in the middle, and we're going to have a less than and a greater than on both, one on each side. So we would put less than on the right, and or actually two less than, sorry. And so we know that x is less than 12, so that's going to go on the right side, but x is greater than 4, which means that 4 is also less than x, so that's going to go on the left, which means that x is somewhere between 4 and 12. Now obviously if you have a greater than and equal to or a less than or equal to, you also need to account for that in there. So you can write it as x is greater than 4 and x is less than 12, or you can collapse it into one inequality. Now let's just quick graph that, point at 4 and a point at 12. You don't have to have all the points in between. You might choose to put maybe 8 because that's quite right in the middle. We need to put open circles at both 4 and 12 and shade in between. So on the previous one, if we wanted to collapse that inequality, x is greater than greater than 3 and x is less than or equal to 6, we're going to go 6 is, 3. That's what we're going to start with. And we're going to say 3 is less than x, which is less than or equal to 6. You can write it either way. However, if you choose to write it this first way we talked about today, you do have to have the word and in between them because you're saying that both inequalities need to be satisfied. The other type of compound inequality we have is an or inequality. That means to solve a compound inequality containing or, you need to find the values that make either inequality true. So we'll take this first one and we'll solve it. It says 7 plus k is greater than or equal to 6. Subtract that 7. K is greater than or equal to -1. Do the same thing with the next one. K is less than, if you subtract that 8, it's less than -5. So you have your two inequalities, x is greater than or equal to -1, or these are k for our variables. K is less than -5. Now when you graph those ones, you're going to notice if you graph that -1 and -5, here's -5, here's -1, maybe I put a -3 between. X is less than -5 is an open circle that opens to the left, and x is greater than or equal to -1 is a closed circle that opens to the right. Notice they have no overlap because this is an or inequality. They do not have overlap. They shade out instead of shading in. So to find a solution for this, it only satisfies one of the inequalities. Each solution does, not both. All right, and so the one difference between, a major difference between an and compound inequality in regards to an or compound inequality, and you can do that collapse where you write it all as one statement. In an or, you can, I see a lot of kids try to go, try to say -5 is, um, they'll say -5 is greater than k, which is less than -1. You can't, or something like that. You can't combine an or inequality like that. Okay, they do have to be separated with that or word. All right, so let's try to solve this next one. Notice it says solve for x, graph your answer. Notice it's just one long inequality. If it's one long inequality with stuff on both the left and the right, this is actually an and inequality, an and compound inequality. So the way that we do this, I'm going to write it a little bigger so you can see it. The way that we do this is if you change one piece of it, you have to change all three. So to start solving, I want to isolate this x, so I got to get rid of this +5. When I subtract 5 in the inside, I'm actually going to subtract it from both ends of the inequality as well. So I'm taking 5 from all three pieces, which is a little bit different in comparison to how we've done things before. Now when I divide everything by 2, I'm going to change, I want to divide by 2, everything is divided by 2. I get -1 is less than x, which is less than 3. Now I'm ready to graph that. I need to have a -1, maybe I'll put a 1 on there, and a 3. Open circles at both, and because this is an and, we're going to shade in between. Now sometimes you might end up with something like -2 is less than -2x, which is less than 6. When you divide by -2 at this step, don't forget you're dividing by a negative, so actually every single one of those signs is going to have to flip. But when you flip both of those signs, you actually want to flip the entire inequality the way you write it. So we always want to have less than, not greater than. So we're going to change that to say -3 is less than x, which is less than 1 when you come across that case. All right, that was the end of lesson 1-5, part B for Algebra 2. Our topic was to solve and graph inequalities and to write and solve compound inequalities.